All right, so today's lesson is going to be over slope as a rate of change. So things we've already kind of talked about, we're just putting it all together. So we're going to review first by doing this warm up, find the slope of the line that goes through these 2 points. Now, there's a couple, I don't know why that happened like that. Okay, so um, there's different ways to look at it. This is just using the formula. Remember what the formula is? It's on your star reference chart. It is the change in y over the change in x. So x, y2 minus y1 over x2 minus x1. So you can look at this first one, it's put 5 minus -1. Well, the 5, that's the y, and this is x. You can see on that one. So that can't be it. And then the next one is -1. That is x. So no, it has to be change in y on top. So 5 minus -4, that one looks good because you got 5 minus -4. And then 4 minus -1. Yes. And then, so the answer is C. You can also do a table, remember, and look at that rate of change, looking at it that way. Either way, it's still going to give you that change in y over the change in x. So when we do the math here, 5 minus -4, you can put it into your calculator, but rules of integers, this changes to plus, positive. So that's 9. And then the change in x is 4 minus -1. Again, integer rules, plus positive over 5. So the slope is 9/5. All right, so now let's look at our objectives. So essential question, how do you use rate to determine the slope? Use data from tables and graphs. Today I am, so that I can determine the slope and y-intercept. I'll know I got it if I can analyze data to determine the rate of change in a real-world situation. All right, so let's put it all together. We've been talking about slope since Unit 3. We know that the slope is when you have a graph, you can just do rise over run, which is your change in y over your change in x. You have, this is slope intercept form. Remember, m is the slope, b is where it crosses the y axis, and then the slope formula, change in y over change in x. So if the rate of change is constant and linear, it's a straight line, the rate of change is the slope of the line. Okay, so that's important information there. The slope of a line may be positive, negative, 0, or undefined. We talked about that. This shows positive, negative, 0, undefined. Okay, again, I want to repeat this right here. If the rate of change is constant, all right, so the same rate of change, and linear, straight line, the rate of change is the slope of the line. All right, so let's look at this data here. It says, first of all, let's look at this right here. Relationships that have straight line graphs are called linear relationships. The rate of change between any 2 points in a linear relationship is the same or constant. A linear relationship has a constant rate of change. The table shows the height of a football after it's kicked. Tell whether this is a constant rate of change. Is this data linear? So constant rate of change, we are going to look at our table and see how it's changing. This from 0 to 18 is plus 18. This goes down 0.5. If we go to the next one here, 18 to 31 is plus 13. This goes plus, up 1. So already you got a negative, you got a positive. This is not a constant rate of change. And now this one's going down and this goes up. So definitely not linear because it's not a constant rate of change. All right, let's look at this one. So determine whether the relationship between the two quantities described in the table is linear. If so, the constant rate of change. Determine the constant. To be prepared to defend your answer. Okay, so all right, so let's look at our y values plus 6. This goes plus 2, plus 6, plus 2, plus 6, plus 2. Okay, y'all can see it is constant. It stays the same. 6 over 2. So this one is linear, and the slope or rate of change would be 3. All right, so determine the constant rate of change and interpret its meaning. Does this represent a proportional relationship? How do you know? Well, you should be able to just look at this graph and know that it's not proportional because it doesn't go through the origin. Now, this is going down, so the graph represents a hawk diving towards its prey. So that makes sense. It's going down, so it's the height or the altitude is decreasing. So what is that rate of change? Now you can just look at, we can do rise over run because rate of change is slope because it's linear here. If it goes from here to here, this is 90. So 90 to this point here is a minus 30. So that's my run, our rise there. And then here to here goes from 0 to 4, so plus 4. All right, so then, oh, I'm sorry, that's 3. Crap, I looked at it wrong. Yeah, so look at it again. All right, so this right here is 3. It's right there in between. So 3, that makes more sense. That simplifies to -10. So the answer is A. So what that means is that the hawk is descending at a rate of 10 feet per second. You can always pause this and review it again, make sure you're taking notes and understand everything. All right, we need to plan a party for the best teacher in the world. Below is a list of the pricing for a party table rental company. Determine whether the relationship between the number of tables and cost is linear. If so, what is the constant rate of change? Prove it. We're just going to prove it by doing what we've been doing. We're going to look at, this is X, this is Y. We're going to look at our change in Y. That increases by 8. This increases by 1. All right, this increases by 6. Interesting. This increases by 1. And this increases by 4. This increases by 1. All different. So it's non-linear, no constant change. So if you look at the data and think about this, what's happening is the more tables you rent, the cheaper the price per table. So the one table is $10. 2 tables, 18, so that means 9 for each one. 3 tables cost $24, so that's $8 for each one. 4 tables will be 28, so it's $7 for each one. But it is nonlinear because it's not constant. All right, the data presented in the table can be presented by a linear model. Okay, so there should be a constant rate of change. What is the y-intercept of the data, and what does the y-intercept model represent? Let's start there. So we've got hours studied, grade earned. Ooh, yikes. 0 hours studied, and grade is a 44. This is X, this is Y. So when the X is 0, that is your y-intercept. So it's 44, and that represents a grade you would earn if you didn't study. What does the slope of this model represent? Well, let's go ahead and determine the slope. So the more you study, like actually this is not constant. So, but if you look at the table, the grades earned half hour were 50, 56, 51. 1 hour, 58. You can see that the more time spent studying, the grade does increase. All right, so we're going to look at a couple of the quiz questions or similar ones. So make sure you're ready for the OMS quiz. Marla, and please make sure you go through the lesson as well. So Marla has a pet hamster. The hamster makes 3 laps around her cage every minute. What is the line what line represents the situation? So you got 4 different lines here. All right, so the hamster makes 3 laps around her cage every minute. So where it's 1, it needs to go to 3. It's 1 minute, 3 laps. So it should be this one right here. Well, you can see that. It is here. So it's B. All right, so this is not proportional. It doesn't go through the origin. It is negative. It's going down. Shows the altitude of a helicopter over time. So it's going down for landing, I'm assuming. What is the slope of the line, and what does it mean in the situation? Okay, so we have to look at our scale here. What is the difference here if it goes from 10,000 to 4,000? And you can also use slope formula here with these 2 points. You can do rise over run if it goes down from 10 to 6, or 6 is the answer. If it goes down from 10 to 4, that's down 6,000. And then the run, it goes from 0 over to 15. All right, so then you want to simplify that. I'm going to pop open the calculator, just do a little math here. This is the computer calculator. It won't let me move it. 6 divided by 15, so it comes out to 400. So down 400, so negative 400 because you have the negative. So if we got our answers, this slope is nope. The slope is negative 400, that's correct. This means that the helicopter descends 400 feet each minute. Yes, because it reduces to negative 400, and if you put that 1 there, that shows you that minute. So it is B. This is positive, that means it would be going up, and then that's the wrong one. All right, you do have a quiz today, so please make sure that you understand everything. Well, I thought you had a quiz today. I'm not sure why it's not on here, but I believe you have a quiz today, and then we have another TFAR for the 4.04. Reach out to me if you have any questions.